We are back with another lesson. In this lesson, we'll solve some numericals on fringe width. So let's take our first question. In Young's double slit experiment, the two slits are made 1 millimeter apart and a screen is placed 1 meter away. What is the fringe separation when blue-green light of wavelength 500 nanometer is used? So let me highlight the important points. So in the Young double slit experiment, the slits are placed 1 millimeter apart. That means your small d equals to 1 millimeter. The next thing they have given is that the screen is placed 1 meter away. So capital D equals to 1 meter. The next important thing they have given is the wavelength of this blue-green light, and the wavelength they have given is 500 nanometer. Fine. So D is 1 millimeter, capital D 1 meter, and wavelength is 500 nanometer. Now let's solve your numerical in your MK system. So let's convert 1 millimeter to meter. So 1 meter equals to 1000 millimeter, or I can also write 1 meter equals to 10 to the power 3 meter. Now if I send this 10 to the power 3 here, then I will get the value of 1 millimeter. So your 1 millimeter equals to 10 to the power minus 3 meter. Fine. Your capital D is already in meter. Now let's convert this 500. N means nano. Nano means 10 to the power minus 9. Fine. So this is your 1 nanometer, which is 10 to the power minus 9. So it's 500 nanometer. Therefore, it will be 500 times 10 to the power minus 9. Meters. Fine. Now, in this question, they have asked you to calculate the fringe separation. Fringe separation means fringe width. And in our previous class, we have derived the relation for the fringe width. Your fringe width beta equals to lambda capital D times small d. In this question, they have given you your wavelength, which is 500 times 10 to the power minus 9 meter. They have given you capital D, which is 1 meter, and small d. The value of small d is 10 to the power minus 3 meter. Fine. Now, now 500 times 10 to the power minus 9 into 1 meter will give us simply 500 times 10 to the power minus 9. Fine. So I will rub this part. Okay. Or just let it be. And then the only calculation left will be here. So 500 times 10 to the power minus 9 divided by 10 to the power minus 3. I can cancel this two terms. So if I take this to the numerator 10 to the power minus 3, if I take this 10 to the power minus 3 in the numerator, what will happen? It will become plus. So this one will become plus here. Fine. And look here, this meter and this meter gets cancelled. What is the unit left? Meters. So the SI unit will be meter. Now what is minus 9 plus 3? Minus 9 plus 3 is minus 6. Fine. Now look here, you have 500. Okay, this 500 I can also write it as 5 times 10 to the power 2. Fine. Now this 10 to the power 2 and this 10 to the power minus 6 will give us 10 to the power minus 4. So I can write 5 times 10 to the power minus 4. And what is the SI unit? The SI unit is meter. So how much is the fringe width? The fringe width equals to 5 times 10 to the power minus 4 meter. And you know 5 times 10 to the power minus 1 times 10 to the power minus 3 meter is how much? This 10 to the power minus 3 meter is millimeter. And 5 times 10 to the power minus 1 is 0.5. So I can also write 0.5 millimeter. So what is the fringe width? The fringe width equals to 0.5 millimeter. Fine. Now let's move to our next question. In Young's double slit experiment, the slits are separated by 0.28 nanometer and the screen is placed 1.4 meter away. The distance between the central bright fringe and the fourth bright fringe is measured to be 1.2 centimeter. Determine the wavelength of the light used in the experiment. So here in this question, the important points they have given is that first of all, what kind of experiment is this one? This is your Young's double slit experiment. So this is your Young's double slit experiment. Fine. Now they have said that the slits are separated by 0.28 nanometer. That means the difference between the two slits D is how much? 0.28 nanometer. Fine. The next thing they have said that the screen is placed 1.4 meter away. That means the distance between the slit and the screen, this capital D, is how much? 1.4 meter. Next, they have said that the distance between the central bright fringe and the fourth bright fringe is measured to be 1.2 centimeter. So if this one is your central bright fringe, then this is central, this is first, second, third, and fourth. This is your fourth bright fringe. So the distance between the fourth and the first bright fringe. Okay, fine. This distance. Okay, the distance of the fourth fringe from the central bright fringe is how much? 1.2 centimeter. This distance is also known as your position of the bright fringe. Okay, since you are measuring this fourth bright fringe with respect to central bright fringe, so this is also the position of the fourth bright fringe. Fine. So x4 equals to 1.2 centimeter. Now in the question they have asked you to calculate the wavelength of the light used. Now look here, this is in nanometers, this is in meters, this is in centimeters. Okay, so we'll restrict ourselves to MKS system, meter kilogram second system. Okay, so I'll convert this nanometer to meter. So 0.28 nanometer equals to 0.28 times 10 to the power minus 9 meter. Let's convert 1.2 centimeter. 1.2 centimeter equals to 1.2 times 10 to the power minus 2 meter. Right. This capital D is already in 1.4 meters. Now since we are looking at the bright fringe, so you know we have already derived the position of the fourth bright fringe, or let us write down position of nth bright fringe is xn equals to n lambda d upon d. Fine. So this n is the order. Which order of bright fringe we are considering? 4. So your n equals to 4. Fine. It is x4 equals to 4 lambda d upon d. Fine. Now let us send this small d to the other side. It will go to the numerator, capital D will go to the denominator, so as your 4 will go to the denominator. Then we can find our wavelength lambda. So x4 equals to 1.2 times 10 to the power minus 2 meters. Similarly, your small d equals to 0.28 times 10 to the power minus 9 meter. On the denominator you have 4 and capital D equals to 1.4 meters. Fine. Again, let's look at the SI unit. This meter gets cancelled. You are left with meter. So the wavelength is measured in meters, as we already know. Fine. So dimensionally, this is correct. Fine. So I'll write down first 1.2 times 0.28 equals to 0.336, and your 4 times 1.4, 14 to the 28, 14 to the 42, 14 4 the 56 is 5.6. Fine. Now look here, 10 to the power minus 2. Okay, 10 to the power minus 2, 10 to the power minus 9. Okay, this minus 9 is very small. Okay, let me just check the question. Okay, so there is slight mistake. Okay, this is not nanometer. Okay, correct this one to millimeter. Fine. Fine, correct this 10 to the power minus 9. Okay, since this will be millimeter. Okay, correct this one. Fine. So if it's millimeter, then it won't be 10 to the power minus 9. It will be 10 to the power minus 3. Fine. Similarly, we have to correct this 10 to the power minus 3 here. Fine. This is 10 to the power minus 3. Now 10 to the power minus 2 and 10 to the power minus 3 will give us 10 to the power minus 5. Fine. Now we know the SI unit, meter. Next, 0.336 divided by 5.6 equals to your 0.06. Fine. Times 10 to the power minus 5 meter. Now 0.06 I can also write as 6 times 10 to the power minus 2. Fine. So your 10 to the power minus 2 times 10 to the power minus 5 is 10 to the power minus 7. Okay. Further, I can simplify it. Suppose if I multiply 6 times 1000, then I also have to divide with 1000. Fine. And then you have your 10 to the power minus 7 meter. Fine. Now 6 times 1000 is 6000. And this denominator I can write it as 10 to the power 3. Fine. Now if I send this 10 to the power 3 in the numerator, it will become 10 to the power minus 3. Fine. Now 10 to the power minus 3 and 10 to the power minus 7 is 10 to the power minus 10. And SI unit meter. So 6 times 10 to the power minus 10 meter is your angstrom. This 10 to the power minus 10. Okay, this part. This is angstrom. So I'll write 6000 angstrom. Fine. So the wavelength of the light used is 6000 angstrom. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.